Here we're going to start with graphing another reciprocal function. We have a parabola as our starting function, which means that we are expecting to see three parts in our reciprocal graph. So I'm going to start by graphing y equals f at x, which is our parabola x squared minus 9. I need to know my vertex, and I know that my vertex is at 0, minus 9 from the form of my equation. So I'm going to plot that on the y-axis down here. To get my parabola, I'm going to go over 1, over 1, up 3, over 1, up 3. And then I'm going to keep going. I'm going to go one more over 1, 1, 2, 3, 4, 5, and then over 1, up 5 on this side. And I'm going to extend my graph. This is my f at x, my original function, is right here. The next thing that I'm going to do is I'm going to graph my reciprocal function. So my reciprocal function, I know, is 1 over x squared minus 9. I know that I have a vertical asymptote from the spot where my original function crosses the x-axis. I can see that that is here at x equals minus 3 and x equals positive 3. So I'm going to add those asymptotes on with my dotted lines, and I'm going to label them. Those are my vertical asymptotes. Those are coming from when my denominator is equal to 0. So I can factor my denominator into x minus 3, x plus 3, which is going to give me my equations of my vertical asymptote. So I'll put VA there, and then I'm going to label them right here. So my vertical asymptotes are x equals 3, x equals negative 3. My horizontal asymptote, anytime you have a 1 on the top, is y equals 0. So I'm going to put that piece on as well. I'll label it with y equals 0. And then I need to figure out what my inverse pieces are, or what my reciprocal points are. So I'm going to start, I'll use black for my original table of values. I've got x and f at x, and I'm going to put some values that I can identify really right here on my graph. So if I have x equals, well, let's do 1. We'll do minus 1,000 as 1. F at x then is going to be 1,000 squared, which is a big positive number. And take away 9, which is definitely going to be positive. I know it's a big number. I don't really need to know what it is. I just know that it's positive. Then I'm going to choose another one that's on the left side there. Let's choose minus 4. Minus 4 squared is 16. 16 take away 9 is 7. So I've got another positive value there. Then I'm going to choose a point in the middle. I'm going to choose 0 for my x coordinate of the vertex. When x is 0, y is minus 9. I already know that. Then I'm going to choose two values on the right-hand side. I'm going to choose positive 4, which is also 7. And then I'm going to choose positive 1,000, which is also going to be a really large positive number. So when I do my table of values for my reciprocal graph, my x's are going to be the same. Got minus 1,000, minus 4, 0, 4, and positive 1,000. And I'm going to do 1 over my big positive value, which means that this value is small. Then I've got 1 over 7, minus 1 over 9, positive 1 over 7, and then I've got 1 over a positive number, which is small, because I know that that number from before is really big. So all this is telling me is where those pieces of my reciprocal function go. I know that when x equals 0, I'm going to do the middle part first. I've got negative 1/9, which is somewhere in between 0 and negative 1. And then I know that I have to approach my asymptotes. My parabola is not going up because I can't cross that horizontal asymptote. On the left-hand side, at minus 4, I've got a value of 1 over 7, which is up here. My value of minus 1,000 is a really, really small positive number. And so I can connect those dots to get the characteristic shape of my reciprocal function. I can confirm with my points that I also have 2 positive values here. And so my graph is symmetric on that other side. Okay, and that is my reciprocal function. This one we will do in class. And then these 3, I'm asking you to find the vertical asymptotes of the following function. We know that this is the x-intercept or zeros of the denominator. And so in order to find my zeros, all I'm going to do is I'm going to set the denominator equal to 0 and solve to find the vertical asymptotes. So I'm going to set the denominator equal to 0 and solve. So x plus 2 equals 0. Therefore, x equals minus 2, which means that my vertical asymptote is x equals minus 2. If I move down, this is the same thing that I had before. In order to find my vertical asymptotes, I'm going to set my denominator equal to 0 and solve, which means that I get x minus 3 or x plus 3 equals 0. So I've got 2 vertical asymptotes at x equals minus 3 and x equals positive 3. And the last one here is a tricky trinomial. I've got 2x squared minus 7x plus 5 is equal to 0, which I can factor to be x minus 1, and then 2x minus 5, which means that I have vertical asymptotes at x equals 1 and x equals 5 over 2. We will discuss the end behaviors together, and those are some examples of how to find the vertical asymptotes of a reciprocal function.